Welcome to Study Loop.
This is the answer to chapter 21, problem number 64 from the Smith Organic Chemistry textbook. And in this problem, we're asked to synthesize two molecules from given starting materials. And basically, we're told we can also use alcohols with 4 carbons or less. But then we can also use any organic or inorganic reagents that we want, which I guess would encompass all alcohols regardless of carbon count. But okay, so anyway, so for A, we are told to start from benzene. And so benzene. Okay, and so basically we're going to need to put a handle on the benzene, but also looking at the final product, I see that there is a double bond in it. There's an alkene, and so my thinking is, given the other problems in this chapter, let's construct that alkene using a Wittig reaction. Of course, there are probably many different ways that you could make this molecule, but I think given the other problems in this chapter, that's probably what they're looking for. So we'll do it with a Wittig. So in order to do that, we're going to make this molecule in 2 parts and then join them with the Wittig reaction. So we'll need to make a Wittig reagent part, and we'll need to make a carbonyl part. And so we can actually, since this molecule is symmetrical, we can actually make them from a common route for the first few steps. So the first thing we're going to do would be to do a Friedel-Crafts here in order to put a handle on this benzene. So if we do a Friedel-Crafts with methyl chloride, that's ugly. That's going to add a methyl group. And so now that we have that methyl group, we can oxidize it with KMnO4. KMnO4 is going to convert that methyl group into a carboxylic acid. And then if we treat that carboxylic acid with lithium aluminum hydride, we can get to the alcohol. And then we can oxidize that alcohol to an aldehyde. So we'll do LAH here, and then water workup. And so that's going to reduce our carboxylic acid that we made to the alcohol. And then if we treat that alcohol with pyridinium chlorochromate, PCC, we will get the aldehyde. And so that's one of our pieces. As I said, we're gonna make 2 pieces and connect them via a Wittig. And so remember, we need to make a Wittig reagent, and we need to make a ketone or an aldehyde, and we've made an aldehyde there. So now we can begin to look at making the second piece, the Wittig piece. And so in order to make the Wittig piece, we're going to start from from our third intermediate that we made above. So we'll actually start from that primary alcohol that we made. So there's our primary alcohol. So again, we would start with benzene, do our Friedel-Crafts, do our potassium permanganate oxidation, and then the lithium aluminum hydride reduction to get to this starting molecule for the second part here. And so we'll take that alcohol, This should be a familiar sequence by now from this chapter. So we'll treat this alcohol with PBr3 to make the bromide in place of the alcohol. And the utility of that, of course, is we can then react the bromide with triphenylphosphine and then butyl lithium, and that's going to get us to our Wittig reagent. So there's our bromide. So we'll do PH3P followed by Bewley. And that is going to get us to our Wittig. Okay, and so now all that we have to do is combine the Wittig reagent that we just made with the aldehyde that we made right above it. And that's going to give us our final product. PPH3 plus aldehyde gives us final product. And so we would get E and Z isomers here, but the problem doesn't stipulate one way or another whether it matters if we get both or if they only want one. So this is fine. And so that's the answer to part A. So then looking at part B, let's see. So what's oh my, what are we told to make for part B? Okay, so for part B, we are told, to make a very similar molecule from benzene and phenol. Okay, and so I will draw this again, draw our target out so that we can see what we are trying to make. Okay, and so this is extremely similar to the molecule in part A. And again, there's an alkene right there. And so probably the way to make this one is going to be to follow the exact same reasoning that we followed for part A. So we'll make a Wittig reagent out of one half, and we'll make an aldehyde out of the other half, and then we'll do a Wittig reaction to construct this molecule. And so what that's going to look like is, let's see. Okay. Okay. So let's make the right side first. So we'll make our Wittig first. Okay, so we're going to start from phenol here. Remember, we were told we can start from phenol and benzene for this problem. We'll start from phenol. We will start with a Friedel-Crafts again. So now we've put a methyl group on our starting phenol. We can then make the methoxide. So we could use a strong base like sodium hydride, and then some methanol. CH3OH. Or actually, no, I apologize. Okay. So we would want to use CH3Br. So methyl bromide after treatment with a strong base. So that is going to get us where we want to be. And so we now have the methoxide here. Okay. And so we can then do a benzylic bromination. So we'll use bromine and light. And again, that because this is an aromatic system, that's going to give us a bromine at the benzylic position here. So benzylic bromination. And then from there, we can make our Wittig reagent. So remember, it's going to be alkyl halide plus triphenylphosphine and then butyl lithium. So butyl lithium, and that will get us to here. Okay, and so obviously this is going to be the left side of our molecule. Okay, so there we go. So there's our Wittig. And again, that's the left side of this molecule. So to construct the right side, we will start from benzene. We'll do a Friedel-Crafts onto benzene. Using this T-butyl chloride rather than methyl chloride. And so rather than adding a methyl group, obviously that's going to add a T-butyl group. Okay, so once the T-butyl group is installed, we'll do another Friedel-Crafts, this time with methyl chloride. And that's going to obviously install a methyl group, para to the T-butyl group. And the point of doing that is that we can then oxidize that with potassium permanganate. Oops. Oof. Okay, so this is similar to the strategy that we followed to construct half of the molecule in part A. So T-butyl group there. That's potassium permanganate is going to give us oxidation to the carboxylic acid here at the benzoic position. And then, and I don't want to put this all on a third page. So what I'm going to do is sort of combine steps here. So lithium aluminum hydride and then a water workup is going to get us to the primary alcohol. And then treatment with PCC is going to get us to the aldehyde. So after this, after the sequence pictured there, what we have is this aldehyde. And so obviously this is ready to react with the Wittig reagent that we made right above it. And so the product of that reaction is going to be our desired product, our final product here. And again, we would get E and Z isomers, but again, the problem doesn't specify whether it wants one or the other or both. So that's fine. Yeah, and so that's the answer to B. And again, the strategy here is just to identify that you can cut these molecules in two at the double bond, and then identify that you could use a Wittig to join the two pieces together, and then go ahead and just make the two things that you need to do your Wittig, the Wittig reagent itself and a carbonyl group. And so that's the answer to chapter 21, problem number 64.